Good morning, good afternoon, and good evening, everyone. Thank you for registering for our webinar hosted by the Institute of Problems of Complex Development of Mineral Resources, IPKON. Let me introduce myself. My name is Marina Bielski. I am the International Business Development Manager for IPKON. There will be three participants on behalf of IPKON in this webinar. Let me introduce to you Dr. Balat Hassen. Dr. Hassen is the director and co-owner of IPKON. He has a PhD degree in technical sciences. He will be available to answer any technical questions you may have. You can ask questions by using the chat function at the bottom of your screen. You can ask questions in English, Russian or French. Vous pouvez poser des questions en français si vous désirez. Мы тоже говорим по-русски и рады будем пообщаться с вами по-русски. Now I will present our main speaker, Dominique Pyong. Dominique is the director in charge of strategic alliances at IPKON. He will speak in details about how to increase the productivity of your mine, how to save 30% on the cost of your roof support technology for your underground mine, and how to increase mine safety with the new IPKON green roof support technology. Dominique, please.
So good morning, good afternoon, good evening, everyone. I will start without further introduction. So rock bolts have been in use as a roof support technology in the underground coal mines in the USA since 1936. Since then, the technologies available have evaluated a great deal. This webinar will review the main types of roof support technologies available, with a special attention to the different types of capsules available. We will start by describing different types of roof support technologies, and will continue with a more detailed description of the three types of capsules available. We'll finish with the case study of a mine that has been using IPKON's silicate capsules. The main types of roof support technologies are friction bolts, thin spray liners, shotcrete, steel mesh, synthetic webbing, cement capsules, resin capsules, and silicate capsules. So let's start with friction bolts. As their name suggests, friction bolts use the friction between the bolt and the walls of the borehole to hold the bolt in place. It is very important that the borehole be of the proper diameter. If the borehole is too big, they are virtually worthless. They provide immediate rock support, but their load transfer capacity is poor compared to resin, cement, or silicate anchored bolts. In addition, friction anchored bolts are more susceptible to corrosion than resin, cement, or silicate anchored bolts. They are not good in friable ground as the bolt does not bond with the rock. Sorry. Thin spray liners. Thin spray liners fall into two main categories based on chemistry. The first category is non-reactive. This is where the applied material gains strength with time, typically as a result of water loss. This is similar to paint technology. The second type is reactive, where the applied material gains strength rapidly as a result of using a catalyzed chemical exothermic system. Thin spray liners or TSLs of various types and characteristics and from 4 to 6 millimeters in thickness are applied to rock surfaces to control key block failure and to assist in localized support. The ease and speed of application of TSLs is an advantage over shotcrete application, and lightweight equipment allows for ease of transport. These TSLs assist in the locking of key blocks, which makes the rock mass more stable. The TSLs also penetrate cracks and joints in the rock mass, which assists in preventing movement of key blocks. TSLs also seal rock, which is beneficial where rock is present, which deteriorates when exposed to air and water. TSLs can be used for the following applications in mines. support between rock anchors, supporting areas with limited access or logistical constraints, limiting weathering, reducing rock burst damage, reinforcing pillars, rehabilitation, and temporary support where aerial coverage is required to protect workers. We'll now speak about shotcrete. Shotcrete is concrete conveyed through a hose and pneumatically projected at high velocity onto a surface. The main type of shotcrete used in mining is dry mix shotcrete. Sorry. The dry shotcrete components, which may be slightly pre-dampened to reduce dust, are fed into a hopper with continuous agitation. Compressed air is introduced through a rotating barrel or feed ball to convey the materials in a continuous stream through the delivery hose. Water is added to the mix at the nozzle. The disadvantages of shotcrete are the following. First of all, the quality of the grout has always been an issue. Very rarely do operators mix grout to manufacturer specification, often relying on the operator's visual observations to determine whether the grout is of the correct mixture. Second, low slump grouts require pumps that can pump a thick grout. The choice of suitable pumps is limited. Third, pumping distance is limited with current grout pumps. Operators often add more water to allow pumping long distance, which adversely impacts the quality and strength of the material. Fourth, grout is mainly supplied in 20 kilogram bags. Therefore, grout waste is excessive when a small number of rock bolts are to be grouted. And fifth, grout strength development is relatively slow in comparison to resin and silicate systems, thus making tensioning of cable systems only possible after hours of cure rather than minutes. I'll now speak briefly about steel mesh. Mine steel mesh provides surface support coverage to loose rock between installed rock bolts in underground mining excavations. It usually provides good control of fall of ground. Synthetic webbing is my next topic. Synthetic webbing is used as a tunnel lining material to control loose and falling debris that often occur during mining operations. The high tensile strength and modulus allows synthetic webbing to arrest falling debris and prevent potentially serious injury to miners or damage to mining equipment and machinery. Synthetic webbing is mostly used in the coal mining industry to complement the specialized system of roof bolting. Synthetic webbing is fitted to the roof bolts bearing plates, acting as a containment system. We will now speak about our main topic, which is capsules. As you probably know, capsules are installed at the bottom of a borehole and allow to permanently fix a rock bolt in a borehole. Three types of capsules are currently available depending on their content. The first type is cement capsules, second type resin capsules, third type silicate capsules. IPKON perceived the following limitations in the existing capsules. First of all, cement capsules. Cement capsules have a short shelf life of 6 months because the shell of the capsules is made with a water permeable material. During their storage, the capsule is affected by any humidity in the ambient air. They need to be soaked in water before being installed. Once installed in the borehole, they take 3 to 5 minutes to stiffen. They allow for a difference in diameter between the rock bolt and the borehole of about 4 to 8 millimeters. Resin capsules. Resin capsules are notably composed of styrene, a highly toxic material. According to the U.S. Environmental Protection Agency, and this is a quote, if inhaled, styrene vapors can cause damage to the gastrointestinal tract, to the kidneys, and to the respiratory system. End of quotation. I have another quote from the US National Toxicology Program. So the US National Toxicology Program has described styrene as, beginning of quote, reasonably anticipated to be a human carcinogen. End of quotation. So, unless the mine is equipped with a very good ventilation system, after installation of resin capsules, a mine usually has to be evacuated of all its workers for 2 to 3 hours to allow for a proper ventilation and an evacuation of the toxic vapors emanating from the said resin capsules. This can have a significant impact on the productivity of a mine. Resin capsules have a short shelf life of 6 months because after this period of storage, the resin contained in the capsules hardens. They should be stored at temperatures below 20 degrees Celsius and can only be used at temperatures between 10 and 25 degrees Celsius. At temperatures lower than 10 degrees Celsius, the resin gets hard and does not react properly with the fixing agent. At temperatures above 25 degrees Celsius, it loses its chemical characteristics and its bearing capacity. These are not re-established even if they are stored at lower temperatures later. They constitute a fire hazard and can auto-ignite at temperatures above 31 degrees Celsius. Sorry. They allow for a difference in diameter between the rock bolt and the borehole of 4 to 6 millimeters. Each resin capsule is in fact composed of two capsules, one inside the other. The inside capsule contains the fixing agent. The diameter of this inside capsule is 4 to 5 millimeters. With resin capsules, there is a high risk that the inside capsule will not break when the rock bolt is installed in the borehole. I will now speak about IPKON's silicate capsules. IPKON invented silicate capsules in order to create a product that presented the advantages of cement capsules and resin capsules without their drawbacks. IPKON silicate capsules are the object of a patent in many countries, and a patent is pending in virtue of the Patent Cooperation Treaty. IPKON invented a new fixing agent for its silicate capsules. Its silicate capsules are entirely composed of inorganic, non-toxic, non-flammable materials. Being non-toxic, the installation of silicate capsules does not require the evacuation of a mine to avoid intoxication by styrene vapors. The stiffening time of the mixture of the silicate capsules is only 1 minute. The shelf life of the capsules is 3 years. They can be stored at any temperature below 50 degrees Celsius. They allow for a difference in diameter between the rock bolt and the borehole of up to 12 millimeters, permitting savings on the cost of rock bolts of up to 30%. Let me explain this. With IPKON silicate capsules, the fixing agent is inside another capsule of a diameter of 17 millimeters. In comparison, in resin capsules, the inside capsule has a diameter of 4 to 5 millimeters. In silicate capsules, the diameter of 17 millimeters of the inside capsule ensures that this inside capsule will be broken and the fixing agent will be released and will mix with the hardener. The savings estimate of 30% on the cost of rock bolts is based on a comparison of IPKON silicate capsules with resin capsules. This is because in IPKON silicate capsules, the diameter of the inside capsule of 17 millimeters allows for a greater difference between the diameter of the rock bolt and the diameter of the borehole. With IPKON's silicate capsules, for a given borehole diameter, you can use rock bolts of a smaller diameter compared to cement capsules and resin capsules, allowing you to save up to 30% on the cost of rock bolts. Furthermore, on average, the volume of the contents of silicate capsules grows by 2 to 3% after its installation, allowing for a tighter installation of the rock bolt. On average, the volume of the content of a resin capsule shrinks after installation. IPKON silicate capsules offer permanent roof support, usually for the whole life of an operating mine. They are easy to install and provide an effective protection against corrosion. They can be installed even in a very humid environment. IPKON silicon capsules have been in use in Kazakhstan since 2009. We will now briefly describe a case study of their use. So the case study will be about the Ritter Sokolny mine. IPKON silicate capsules were thoroughly tested and used in the Ritter Sokolny mine owned by Kazink, which is itself owned at 51% by Glencore International. This mine is situated in the East Kazakhstan region. I have a quote from Yuri Sitnikov, who is the director of the mine. He said, and I quote, after testing IPKON silicate capsules, the mine switched from resin capsules to silicate capsules as its sole type of capsule for roof support technology. End of quotation. So, in this case study of the Ritter Sokolny mine, bore holes were drilled to a depth of 1.6 meters with a diameter of 32 millimeters. In said holes, rock bolts of a 22 millimeter diameter were installed. To fix the rock bolts in the hole, IPKON's silicate capsules were used. In each hole, 1.5 meter long capsule with a diameter of 27 millimeters was used. On a surface of 1 square meter, 5 rock bolts were installed around the perimeter at a distance of zero point 0.7 meter from each other. The details of the attachment are shown in the picture that you can now see. You have in fact three drawings. The first one at the top left corner, it shows a longitudinal view of the installation. The second picture on the top right corner shows you a lateral cross-section view of the installation. And the picture at the bottom of the screen shows you a view from above of the installation. The tests that were made at the Ritter Sokolny mine allowed us to come to the following conclusions. First of all, the bearing capacity of the rock bolts installed with IPKON silicate capsules exceeded 110 kilonewtons 10 to 20 minutes after the installation of the rock bolts in the boreholes. That is comparable to the bearing capacity of rock bolts installed with resin capsules or cement capsules. Second, the operations of the mine can be continued without interruption right after the installation of the rock bolts and the silicate capsules. So in this case study of the Ritter Sokolny mine, rock bolts of a diameter of 22 millimeters were used in boreholes of a diameter of 32 millimeters. A review of the use of IPKON silicate capsules in said mine notes that over the 4 years of experience of working with IPKON silicate capsules, there have been no adverse event associated with the anchoring operations. The review confirmed IPKON silicon capsules' reliability in securing the rock bolt in the hole and the cost effectiveness of their use. As mines get deeper, there are challenges associated with providing sufficient load transfer capability in primary and secondary roof support systems. Having bolting products that can cope with increased stress loading, squeezing, and dynamic loading capability is becoming increasingly important. To conclude, IPKON has been selling its silicate capsules with a lot of success in Kazakhstan underground mines since 2009. IPKON is looking for opportunities for its silicate capsules in the civil engineering and construction markets. IPKON wants to find partners worldwide who would be willing to act as its licensees to sell its silicate capsules abroad, both in the mining sector and in the civil engineering sector. Dr. Balat Asien, director of IPKON, will be in Johannesburg in South Africa from December 2nd to December 4th. Dr. Asien will also travel to Canada in February 2014 and to Australia in April 2014. We will be looking for collaborators and local places to test our silicate capsules, such as laboratories, research centers, rock bolt producers, and underground mines. Anyone who could be interested in acting as a licensee for the silicate capsules should contact us. Uh, our email has been mentioned at the bottom of the screen. It's dpion at ipkon, IPKON dot KZ. We can also be reached on the phone in Canada. The country code is 1. The number is 514 516 1178. We invite you to fill a registration form by going to the press release section of our website. Our website address is www.ipkon.org. I thank you very much for your attention and wish you a very nice day.
Thank you very much, Dominique. So we invite to continue this discussion on the pages of our e-magazine, Rock Mechanics and Underground Support. And if you are interested in helping us test silicate capsules, or you are interested in buying a license or selling silicate capsules, we invite you to fill in the application form, which you can find on our website in the section press releases. So we hope to hear from you soon. If you want to use green roof support technology, if you want to save on cost of your roof support technology and to increase the productivity, this is a good decision. Thank you very much for your attention and have a good day.